Hi everyone, welcome to the course on Learn Redis in-memory database from the scratch. So in this video we are going to discuss about the course overview. What are the topics we are going to cover throughout this whole course? So for this course I have mainly divided the full course into 4 major sections like Introduction to Redis, how to install the Redis on a Unix and a Windows based system, what are the commands, what are the data structure associated with the Redis, and what are the persistence mechanism available in a Redis. So in an introduction part, we'll try to cover the major theory associated with the Redis. Every single section has been covered with a quiz to test your knowledge that whether you have really grasped the concept or not. In the next section, we'll see how to install the Redis on a Unix or Linux based Ubuntu system and a Windows system. Then we'll move to the Redis Basic command like how to set single or a multiple key value pair, and some more command like expire, TTL, increment, decrement. We'll see commands like scan, count, match, all the configuration related command, how to change the configuration through this command, and then we'll see about what is the major data structure available in a Redis like a list data structure, set, and a hash data structure. Every section covers with a quiz. So then to test your knowledge, quiz will come associated with the Redis command and a Redis data structure. In the last section, we'll cover about what are the persistence mechanism available in a Redis. Redis is already a in-memory database, but still you can preserve your data, you can persist your data with 2 different mechanisms like RDB mode and in a AOF mode. We will see the theory associated with both RDB and AOF. We'll see the advantage and the disadvantage associated with both of the mode, which mode you should prefer when, and we'll see both of the mode into action, how to enable and disable both the mode. So that's all about this video. I am very much excited to get started. So see you into field. We'll start with a very basic introduction of the Redis from the next video. Hi everyone. So this is the first section on introduction to the Redis. So throughout this all the lecture in this section, we are going to learn about what is Redis. We'll introduce what is Redis database, what are the features and functionality, its security and authorization model associated with this Redis. So let's start discussing what is Redis database. So Redis is one of the open source tool. It is a in-memory database. So you can consider it like a very fast retrieval, high performance database. All the dataset resides in a memory. You can use for a caching purpose, so you can consider it as a like a cache database also. So what kind of data this Redis kind of database store? You can consider this Redis is equal to the partial functionality of NoSQL MongoDB plus partial functionality of, you can say, like a memcache. So what does it mean? So MongoDB stores data as a kind of key value pair. So every value whatever we want to store is associated with the key. So that is the same way Redis also stores the data. But Redis store lots of different type of data structure, so like a hash, chat, list, and many more data structure it will support. And memcache also runs in memory. But there is a one subtle difference between this in-memory Redis database and a in-memory memcache database. The difference is that whenever you restart the server, all the data available in a memcache memory will be lost, and again you need to load it. But in case of Redis, while those data is available in a RAM, it also persists this data onto disk also. So whenever you restart the server, automatically those data will be loaded into memory. So after restart, there is no need to reload the data, but in case of memcache, it requires to load those data. So that is a basic difference between this memcache and a Redis kind of database. So that is one advantage this Redis DB will give over this memcache, and it stores the data as a key value pair like a NoSQL MongoDB, so document oriented data set. To store the value as a different kind of data structure, it will store it. So it just not supports like a string, but you can store the value as like a hashes, or you can store it like a list or a set, or you can use like a sorted set, bitmap type data you can store it, or geospatial data you can store it. So value can be lot of different data structure it will support. Let's discuss about the Redis scaling functionality. So already Redis is running on a one single machine or one single instance. So in terms of scaling, Redis, it's not very easy things to scale in case of Redis, because Redis is not meant for high performance distributed cache database kind of functionality. So whenever, let's say, you are running Redis on one particular machine and you want to horizontally scale for multiple different machines, it's not that easy task in case of Redis, but you can create multiple instances of Redis. So apart from that, you can access this Redis database from number of different libraries. So let's go to redis.io/clients. So you can see whatever language you are currently your application is running, from any of the language you can just there is a libraries available for that particular language to access this Redis dataset. So whether it's R language or C, C#, C++, or PL SQL, Python, Java, from any of this programming language you can just call this Redis dataset. So Redis supports multiple IO clients. You can just go to this redis.io/clients. So that is what a little basic introduction regarding to Redis. In the next video we'll continue our same discussion on some more feature associated with the Redis. I hope you enjoy listening this video, and see you into next video. Hi everyone. So let's continue our discussion on introduction to the Redis. So let's compare this Redis with the normal RDBMS or NoSQL kind of MongoDB dataset. So all those dataset stores kind of raw data, but Redis is not meant to storing this kind of raw data. So Redis is not meant to store this way the raw data, but you can consider Redis as one of the data structure storage. So different data structure like a hash, set, list, all those data structure it will directly store inside the RAM. In case of relational database management system, you need to define like a schema, but in case of Redis you no need to define any kind of schema, or no need to define any kind of column for a particular key value or anything actually. So there is no structured information, table like structured information you are storing inside the Redis. So no need to define a schema, no need to define a column. Redis is mainly used for how much advantage you can take of the Redis speed of a high performance data retrieval. So Redis kind of just put your data, Redis will put it into memory, and with a constant amount of time it will just retrieve those data. So that is what basic main characteristic of this Redis. In a constant amount of time you just put your data into memory, and in a constant amount of time you can just retrieve those data set. If you think in terms of retrieval, in case of RDBMS, whole table scale will happen, or even if you have created the indexing of this particular table or particular column of that particular table, in that case entire table level indexing will happen, indexing scan will happen. So whenever you want to retrieve any kind of data in RDBMS, whole table retrieval or entire table indexing scan will happen. But in case of Redis, you just put your data and immediately while retrieving type, it goes to that particular location of memory where the data reside in case of Redis. So let's say you are storing some data like a, let's take example like a key 1, you are just storing as a val 1. So when you put this data, it resides to one particular location into memory. So it just calculate it hash value and put it into one particular location in a memory. The value will be val 1. So while retrieving time also, it's a in a constant amount of time, it just retrieves those data. So based on the key 1, it finds the hash value, and from that hash value it just locate to that particular memory location, and in constant amount of time it will retrieve those data. So in case of Redis, there is no query language like a RDBMS. In case of Redis, it's up to you that how you want to store the data. So the better way you store your data as per your business requirement or your application granularity, it depends on that particular data structure, that how you store the data, how fast you can retrieve that particular data set. Now I have just shown you the example like you can store key 1 as a kind of value 1, so you can just retrieve this value based on this key 1. But you can store in case of Redis like a 2 keys associated with the val 1 also. So let's say one single Redis database has been accessed by 2 different clients, and both of the client wants to access the same value through 2 different keys, because they don't want to get shared among different applications. So in that case, you can just associate this key 2 also as a val 1. So multiple key also can be associated with a single value in case of Redis. Okay, so these are some of the basic features of this Redis dataset, and we have seen about it how Redis has been compared to SQL related database like RDBMS dataset. So that's all about this video. In the next video, we'll continue our discussion on security related features of this Redis. I hope you enjoy listening this video, and see you into next video. Hi everyone. So let's continue our discussion on Redis introduction. So in this video, we'll discuss about what is the security related functionality this Redis database will offer. So Redis is not very good. I mean, it's not completely secure, because this security related part has not been very well implemented in case of Redis. So it is a highly recommended and good practice that allow only trusted client to access the Redis, and just discard all those client apart from this trusted. Still you can set up a very simple basic authentication. So you can set up with a simple plain password, and all those password also resides in a plain text format in a redis.conf file. Inside this redis.conf file, you can just put all those IP address and a port from which you want to access you want this Redis to get access. So you can just list down all the client IP address, and after that you can just restrict your access to that particular interfaces. So access through binding. So it is recommended practice that don't rely on a Redis security feature. If you want to expose this Redis to the outside world, there is always highly recommended practice that you set up your firewall at a OS level only. So at OS level only, you can just discard some of the call, or you can accept some of the call. So try to control this call at a firewall level only, because Redis is not very good at this kind of security feature. And always you can just restrict your access to one of the main port where Redis is running. So Redis by default will run on a 6379 port. So you can restrict it uses on that particular port. You can enable the authentication mechanism available in a Redis. So there is one parameter associated with this particular file, the configuration file of this redis.conf. So you can just enable that particular feature. And once you enable this authentication feature, after every single call from any of the client to Redis server or Redis dataset, there has to go through this auth mechanism. There is one very bad thing that if somehow your system has been cracked or accessed, this password is stored in a very plain password, so plain text. So if your system is hacked, they can easily get this password through this redis.conf file. So while transferring your data from client to your Redis, there is one very bad thing about the Redis is that Redis doesn't encrypt your data. So no encryption at a Redis end. So it is a recommended practice that you transfer your data to some secure channel like SSL security from your Redis client to your Redis server. Redis supports commands like config. So only admin can access those configuration level commands. But if somehow someone else is trying to access this config related functionality, in that case Redis is providing one renaming of command. So you can just rename this config command to very strange thing like config to, let's say, very random some strange string, strange number. And after that, if you want to access any functionality of this config level, you just do not need to write this config. Instead of that, you can just put this string. Okay, so Redis is providing these are the things for the security level, but not recommended practice that you use the Redis security and you just rely on this Redis security while exposing Redis dataset to the outside world. Okay, so don't rely on the Redis security. But apart from that, Redis provide this simple basic auth mechanism. You can just enable through this Redis conf file. Once we install this Redis, I'll show you that what are the configuration parameters are there. You can restrict your access for some of the IP address, and highly recommended practice that don't rely on this security feature. If you want to rely on security features, set up firewall at OS level only and control all the calls happen to this Redis through this firewall only, and restricted access to this particular port where by default this Redis is running. The password is stored in a plain text password, so not recommended, but still Redis stored the password in a plain text only. Data is not encrypted, so use the SSL layer to encrypt those data. And apart from that, Redis is providing one more functionality to renaming your master config command. So when you want to access this config command next time, you can just use this long strange string. Okay, so that is all about the Redis security model associated with the Redis. I hope you enjoy listening this video, and see you into next video. We'll start with the Redis installation. Hi everyone. So in last video we have seen how to install this Redis on a Linux based Ubuntu variant. Now in this video we are going to see how to install on a Windows based machine. So let's just go to the Redis download. So very first link, redis.io/download. Now if you go here, if you visit this link, you will find that there is no Windows official link is available, because Redis do not support the Windows based machine. So there is a very unofficial one. Microsoft Open Tech Group has created this Redis installation on a Windows. So you can go to this particular link on GitHub from this Microsoft archive/redis/release. Link I will put it into description. So let's just go to this particular link, and you can find the very first one, which is the latest release from this Microsoft archive. Now if you see this Redis, the Redis is already available in a 4.0 version, but here it is 3.2. so in case of Microsoft it's still outdated, but I will show you the installation process. It is not recommended to anyhow use this Redis on Microsoft operating system, so it will take some time to download. Okay, so download has been finished. Just double click on it and just run it, and just simply follow the instruction, accept the terms and agreement. It is asking me that add this Redis installation path to your folder to your path environment variable. So just select it because we want to run this Redis from anywhere, and default path of this installation is C drive program files Redis. Next, add an exception to your firewall, yes, allow, and then we want to run this Redis on a default port 6379. Set maximum memory limit, nothing we need to set up, just install it. It will ask you the permission to get it installed on your Windows based machine, so just press yes. Very lightweight software, so it won't take very much time to install. So okay, it's finished. Okay, so Redis has been installed. So let's just go to the command line prompt of this Windows, and we'll just type Redis -server. So you can see that it is creating the server and listening to this particular socket, so 6379. Now let's open the Redis CLI, so command line interface to access this Redis engine. Okay, so we are got connected. Now let's define a very simple function, simple command like let's set hello is equal to 10, and let's just get this hello, so hello is equal to 10. Okay, so in this video we have successfully installed this Redis Windows based machine. Even though this Redis community doesn't officially support their Windows version, it is not even available on their website. So this is an unofficial way through this Microsoft archive page. We have downloaded this MSI installer and we have installed on our Windows machine. So that's all about this video. See you into next video. Hi everyone. So in this video we'll see about how to install this Redis server and a Redis client on one of the Linux based variant Ubuntu. So I am already on my Ubuntu instance. So I have bought this machine on a DigitalOcean cloud computing environment, and I just connected through this SSH client. So I am inside this Linux box, Ubuntu box, you can say. So first task is we will do apt-get update, so it will update all the repository packages. Next is apt-get install Redis -server, and it will install the Redis server. So by default, as a part of Redis server, one Redis client, so Redis -CLI command line interface is also available. Let me just clear it. So let's start this Redis server. So you can see that Redis server has been started immediately. So this is the Redis version we are using on a 64-bit machine. This is a process ID associated with it, and now we are running on a port 6379. So it is a by default port when you start this Redis. Let's open the another tab. Okay, and from another tab we'll start the Redis client. So Redis -CLI. Okay, so you can see that it is connected to this particular port 6379 here. Let's put some very simple data, like let's say we want to set key 1 as a val1. So that has been connected to this particular server and it has stored this data into RAM. Now let's say we want to retrieve this data, so get key 1 is equal to val1. We'll see into much more detail into future video all the commands, all the data structure associated with the Redis. So that is what the basic setup of this Redis. I'm just disconnecting through this Redis -CLI. Now let's go to this. I'm using this nano editor to see the configuration file. So etc/redis.conf. So this is where this Redis configuration file resides. So you can enable, disable a lot of security feature, password, and everything. You can just control it through here. So I'm just opening that particular file. So you can see there are a lot of different parameters where you want to persist your data, what are the address you want to bind it on, which particular port you want to run your Redis. So, and everything is you can configure through this particular one single file only in case of Redis. So let me just, okay, so that is what about the basic installation of this Redis on Ubuntu machine. That's all about this video. See you into next video. We'll see in depth all the commands associated to deal with this Redis dataset. Hi everyone. So welcome to the section on Redis Basic command. So in the last two sections we have seen a Redis theoretical aspect, what Redis is, what is the characteristic of Redis database engine, and we have successfully installed on two different operating system like Ubuntu and a Windows operating system, this Redis server. Now in this section we are going to learn about majority of all Redis command. So what are the data structure of that, what are the basic command associated with that. So let's begin our journey with a very simple command. So before that, let's just start this Redis CLI. Oh, it says that could not connect Redis to this particular port, connection is refused. That means Redis services are not running. So I can just start like sudo service Redis start, and we can just grab like Redis -CLI. Okay, so we are back to the prompt of this Redis CLI. Let's start with a very simple command like a ping. So once we fire the command like ping, it should return a pong. That means all the service on Redis is running fine. Let's start with another simple one like echoing. So let's say echo hello. So it will just return whatever you give as argument to this echo function. Now let's set very basic some key value pair. So for that we are going to use this set command. Let's set to the hello, let's say 10. Now we want to grab this value associated with this key hello. So here the hello is equal to key and 10 is equal to value associated with the key hello. So get hello, hello is equal to 10. Let me just get through this hello. It returned nil. That means this key doesn't exist. That means that the keys in Redis database engine are case sensitive. So this hello is treated completely different than this hello has been treated. One more thing that I have written a command like set and get in a uppercase letter, but they are not a case sensitive. You can write like in a lowercase letter like set and either in uppercase or either in a lowercase. So they are not case sensitive, but the keys are a case sensitive. Now let's apply a very simple one like a increment. So increment, let's say hello. Okay, so it has written 11. Let's again increment it. So return 12. Now if we just grab get hello, it has written 12. Same way we can use the decrement. Okay, so we have decremented this counter from 12 to 11. If we just grab this get hello, it become 11. We can again decrement it, and again you can check get hello is equal to 10. So we started from 10, we incremented through this 11, 12, again we decremented from 12 to 11 to 10. So we are back on track. Let's just again decrement it. So hello is equal to currently 9. Now let me set one more key, and I will show you what are the more commands you can apply on the top of this. So hello is equal to, let's say, 9, so we'll write another key like a world is equal to, let's say, 20. Now suppose we want to find that whether particular key exists in Redis current live memory or not. So we can use exist world. So it has written integer 1. That means that particular key exists. I'll just do exist world 1. So return integer 0. That means that particular key doesn't exist. Now we have total 2 keys are available, like get hello and get world. Okay. So hello is equal to 9 and world is equal to 20. Now let's say I want to delete hello, or I'll just delete world. Okay, so it has written integer 1. That means it has successfully deleted that particular key. Now let's just grab this get world. So return nil. That means this key doesn't exist. Okay, now let's me just come out from this prompt. So I'm just pressing Ctrl C and I am just out from the port. So let me just clear it. Now we have started this Redis -CLI. So we entered into command prompt of this Redis CLI and we just fired command all those one by one. Now let's say we want to fire those command from the outside world or without entering into this Redis CLI command prompt. So we can use like Redis CLI. Let's say I'll just write echo hello. So it is echoing the hello. So that means without entering into this Redis CLI command line prompt, it has returned this hello. Now let's say another command we want to fire. Let's say hello is equal to, I want to put like a, I'll make another one. We have already taken this hello. So let's take a foo is equal to 25. Okay, that is an error because we need to set. Okay, now let's just grab this foo, whether it's a 25 or not. Okay, 25. So we are out from this Redis command line interface port, but still Redis server is in as a service is already running in a background. So in this video we have seen a lot of commands like how to set a single value, how to grab, how to increment that particular value or decrement, how to delete, or how to find whether that particular key exists in the Redis database memory or not. So that's all about this video. In a next video we'll see some more command associated with the Redis. Hi everyone. So let's continue our journey on a Redis basic command. So we have gone through a couple of commands in a last video. In this video we'll extend our journey of this Redis command further ahead. Last video we have seen without entering into this Redis prompt fire some of the commands and we got the output on this ubuntu command line prompt only. So let's say we want to persist this data or whatever the output we got, we want to persist into one particular file. So how we can do it? So I'm just grabbing this, let's say echo hello, and I want to write into file like, let's say a.out. I just write into a.out. Okay, so let me just see whether a.out has been created or not. So you can see a.out is available. Let me just open this. We'll use this nano editor to open it. Okay, so you can see hello has been printed. Let me just fire another command like set foo is equal to 25, and I'll just again write into a.out. It will be overwritten in this case. So whatever output came after firing this particular command has been written into this particular file. So this type of thing will be helpful when you have a large amount of data came as a output after firing some few or just couple of or single commands on this Redis database engine, and you want to analyze that output In that case, it is very much helpful. So we have successfully executed. Let me just open this nano a.out. It says that it's okay because it has written just the okay only. Instead of that, if we just fire like get foo, so it will return 25. It will write this 25 to a.out file. Okay, so 25 has been written. Okay, so now let's see some of the monitoring tool of this Redis. So I'm just clearing my screen. Okay, and I'm just creating another tab, like a duplicate tab, so it will connect to on Ubuntu. Okay, so in a second window, what I just started, I am just starting this Redis -CLI. Now suppose from one side of this command line also I am starting this Redis -CLI in both the window, and I want to grab in one particular window what are the command I am just firing on this Redis engine. So let's say I'll just put command like echo hello. So at the other end of this Redis client, I want to monitor it. So for that, Redis is giving like command like monitor. Okay, so it started listening that what are the commands are coming. So I am just making my window little small, so you can detach this tab. So there is another tab where I started my monitor command, and this is the tab where I'm just started this Redis command line interface, and from that I'm just going to fire some command. So let me just fire echo hello. So you can see it has printed as a log this echo hello. Let me print like set hello is equal to 20. So set hello is equal to 20. Get hello. So the moment you start fire this command, immediately this entry has been logged through this monitor tool of this command line interface. Now let's see some more concept associated with this commands. So let's say instead of just writing simple text like a hello, we want to use the namespace. So let's say we want to set the key like user, and I'll just make a user, let's say name. So we'll give name like let's say John, and same way we want to set like a age of the John. Let's say age of the John is 35. So there is a two query we hit. So one is user name is John and user age is equal to 35. So earlier we didn't use this colon command. So through this colon we can use the namespace kind of functionality. Now suppose we want to grab, I should not write just the name because it looks like a word, but name of the user, age of the user. So same way user name, so it's a John. Same way user age, so age equal to 35. Now let's see one more important command like a expire. Now if you have seen all the command what we have fired till now, that all resides inside the memory till you do not shut down your Redis services. Redis got shut down, so till that time it resides in a memory. But suppose for some of the key value pair data you want to reside in a memory for certain amount of time. So let's say you want to retain that particular key for 10 seconds only or 20 seconds only. So how we can achieve it? So for that we can use the expire command. So we can use expire, and I'm just going to create let's say foo is equal to 20. Let me see what happens. So it has written 20. Now if I want to monitor that what happens to this foo key, so 8 seconds has been left. So we can use this ttl command. 4 seconds has been left, 2 seconds left, -2, that means the time is over. Now suppose I want to grab whether this foo exists in DB or memory or not. so it's a 0, that means it doesn't exist. So we have seen a lot of commands in this video. We have started from very simple get and set commands to we have reached to how to use this expire command, how to save your output into one particular file in this video, and we have seen how to monitor what are the query you are sending to database engine of this Redis. So that's all about this video. See you into next video. We'll see some more commands. Hi everyone. So let's continue our journey on this Redis commands. So we have already seen through a very simple command like a set and get. Set. But this set and get commands are kind of limited. So if you want to just set one particular key value, it will be helpful. So let's say at a single moment or a single command fire, you want to set the multiple value. So for that you can use mset, so multiple set, and you can just give value like key 1, let's say val 1, or let me make some meaningful word like hello, we'll make it 20, and another key I'll just make it into quotes, and let's say another one will write like a key foo, and its value will be bar. So in this command we have set the total 2 key. One is hello and another one is a foo. Hello's value is 20 and foo value is bar. Okay, so we have successfully set it. Now let's say we want to grab just a hello. So hello is equal to 20. Foo is equal to bar. Now let's say instead of just grabbing one particular key, if I want to grab multiple keys at the same time, so I can use multiple get. So mget hello foo. So it has written the 2 value. So one is 20 and another one is a bar. Now let's say I want to append some value to some particular value of this any of the key. So I can just use like a append, and let's say this bar value has been associated with the foo. So associated key value associated with this key foo, I want to append like a, let's say I'll just make 100,002. So bar 1002. So let's just get this foo. So bar space 1002. So 1002 has been appended, space 1002 has been appended to bar. Now let's say I want to rename one particular key. So let's say we have already foo is equal to bar 1002, and let's just rename this foo to foo 123. Okay, now suppose I just use this exist foo. So foo doesn't exist, but foo 123 will exist, and if I just get this foo 123 will be bar space 1002, what we have just now said. So in this way you can rename one particular key also. Now let's say we want to grab some particular set of character based on the index value. So here we have a bar space 1002. So there are total 8 characters are associated. 3 is here, then 1 space, that means 4, and another 4. So there are total 8 characters are there. Now suppose some portion of that character I want to grab like a substring of value. So I can use like a get range. So get range. My key in this case will be foo 123. And let's say I want to grab from 0th character to, let's say, 4th character. So it has written me 0, 1, 2, 3 and 4. So 0 and 4 both are inclusive. Let's grab for 8. Let's see what happens. So it has written all the value. Suppose you don't know the length of the value, so you can just grab like a -1. and it will return the full string. Let's grab for just 3. So bar, I just want to grab just the bar, so I can just use 0, 1, 2 because there is total 2 characters only. So let me just clear the screen. Now suppose you don't want any of the key value pair we have stored into database engine or Redis database engine, and you want to flush all those values. So there is one command like a flush all, and once you fire this flush all, it will just simply delete all the keys available in a memory. So I'm not going to fire this thing because it will just flush all the value we have just now set. So in the last video I have shown you one command that how you can make one particular key as a expire after certain amount of time. So let's say you put or fire some command that after certain interval, or let's say after 50 seconds, this particular key should expire. But in between time you literally feel that no, I don't want to get it expire, let it just revert it. So how you can again persist it and remove that expire functionality for that particular key. So let me just set this expire. Let's set foo 1 2 3, what we have already. Let me just set it for 50 seconds. Okay, now we can just monitor through this foo 1 2 3. So only 43 seconds left, now 40 seconds left. Now in between you started thinking that, oh, I don't want to remove after 50 seconds. So you can just use like a persist foo 1 2 3. So it has written 1. Now let me just again monitor through this TTL. So it has written -1. So whatever the expire part what we applied on this foo 1 2 3, it has been removed. Say don't get it expire after 50 seconds, as previously we have told through this command expire foo 1 2 3 50. So that's all about this video. We have seen a lot of commands of this Redis database engine. Future video will see special data structure available in a Redis like a list, hash, set, sorted set, and all those things we'll see into future video. So that's all about this video. See you into next video. Hi everyone. So let's discuss about two important commands in a Redis database engine. So one is a scan and one is a match. So we have already seen that if we, let's say, want to grab some particular keys, so we can use this get or mget command, and we can just retrieve the value associated with the particular key. Now let's say we want to find all the keys are currently present in a live memory or in a Redis database engine. So let me just flush db, so it will just clear out everything. And for that we have two commands are available. So commands are like keys, and we can just press star. So I have already flushed, that means empty list or set, there is no keys are currently available in a memory. So let's just populate with some random keys, or it will automatically populate this for debugging purpose only. So populate, let's populate the 50 values. Now let's use this keys star, okay, not key. So it has written all the 50 value. So it has created like a key :5, key :36. So from key 1 to key 50, I guess it has created. Let me just clear it. So one way we can grab all the keys like through this keys star, but it is not recommended to use this keys star in case of production environment, because it will just block everything. Let's say you have a huge amount of keys are present in a live memory. So in that case, while retrieving all keys from the memory, it will just block all other operation because it's a single threaded application, so it is not recommended use. But when you are developing your application, in that case, for debugging purpose, you can always use it. And instead of just retrieving all the keys at a one shot, we can use like a scan. Let's say we'll start with a scan 0. So it will return us the two value. One is a next iterator and another one is a by default it will return us yes the 10 value. Okay, so 11 it has written, so by default might be 11 has been written. Now suppose if we want to grab the next set of values, so we can use like a scan 60 because it is saying that if you want to grab, just use this next iterator scan 60. Okay, so another, now it has written 10 value only, so another next set of value if you want to grab, like let's say next scan 54. Okay, another sets of value it has written. Now suppose instead of every time this 10 value, if I want to grab, let's say scan, now I want to use this 5 because next set iterator cursor it will give. So I'll just want, let's say, count 7 value only. So from that particular cursor 5, it will just return the 7 value. So we have already retrieved 10, 10, 10, 30, and this is the 7 value we have returned 37 value. Now let's just grab, we'll have to use this 51 now, and I'm just grabbing random 100, so it will return remaining all value might be. Okay, so remaining 12 value. So we have first retrieved 11, then 10, and then 10. So 31 and then 38. This is a 38. So including this 7 and 38 plus 12, that means it's a 50 value. So we have successfully retrieved this value. So this is a cursor based scanning. So after every particular, you can consider it like a pagination. So after every one page it will retrieve the result, and with each page it will return one cursor where we should point to the next set of keys it will return. Now let's just grab this key. What is the value it has put this inside this key 18? So there is a value 18. So this way it has for the debugging purpose automatically populated this 50 value for us from key 150 to value 150. Okay, so we have seen about how to use this scan command. Now let's use the matching command. So for that we can use like a scan match, and I'll just use key star. I need to use scan 0. Okay, so it will just return all the key which is having a particular pattern matching. Let's say I'll just use Z star. So empty list, that means there is no pattern exists with this particular Z star. But with the key star it has written us 11 value at a very first glance, and it is saying that use this next 60 to match another set of pattern. So another 10 it has written with a 54 is the next iterator. So in this way we can use this pattern matching, and based on that pattern matching only it will retrieve all those keys. So in this video we have seen about two important command, like three important commands. So one is the keys, another one is a scan. Keys is to retrieve all the keys associated currently resides in a memory. Scan is a iterator based key retrieval, and another one is a match. So based on the matching pattern only it will retrieve some particular sets of key which match those pattern. So that's all about this video. See you into next video. Hi everyone. So in this video we'll discuss about what are the configuration and related information are already stored in a Redis database engine. So what are the configuration related properties are set in a Redis database. So let me just enter into Redis command line interface. Okay, so let's say we want to grab all the property currently set on a database engine. So we can use the config command. Config get star. So it will return all the property currently set on a engine. So you can take any one of them, like a REPL, disk list, sync. It is currently set to no. Let's say we want to grab some particular property, like port number on which this engine is running. So it's running on a 6379 port. Let's say based on some pattern matching you want to grab the property like bin star. So it will return the bind address. So it is engine is currently bind to this particular address 127.0.0. Now let's say we want to get some information related to server. So we can use the info command. So there are a number of parameters are there, like, and all the information related to server has been grouped into some particular sets of commands. So these are the commands are associated with the server. So it's a server git shell, server git dirty, and server config file. It is a client related information. It's a memory related information. So let's say we want to grab some specific information like info, let's say memory. So it will return the memory related information. Let's say we want to grab the CPU related information. So it will return the CPU usage and all those things. Now suppose, let's say we want to know some information associated with some particular command. So let's say get or set. So we can use command info get. So get related all information it will return. So let's say we want to get for information related to set command. So set related information it will come. So mainly it's for return and it's for read only. So it's very much faster, they are saying. Now suppose we want to know how many total commands are there in a Redis database engine. So we can use just simply command count. Now let's say we want to find what are the total number of clients are currently connected to Redis database engine. So we can just simply use client list. So it has written one value. So that means one particular Redis client has been connected. Now let's say I want to set some particular name to this client. So I can just use client set name. Let's just give the RC1. So Redis client 1. Okay. Now suppose I want to know the name of the particular client connected to Redis database engine. So I can just use client get name. So it's a RC1. Okay, so that's all about this video. We have seen a lot of configuration related function command in this video. So how you can use the config, mainly the config and info command will give you the majority information associated with the server currently. So through these two commands from the Redis command line interface, Redis CLI, you can get a lot of information about the server. So that's all about this video. See you into next video. Hi everyone. So let's discuss about one of the very important data structure, list. So this list data structure mostly available in majority of all programming languages has been implemented. So in this video we'll see what is the functionality of this list, how it is helpful, what is the use cases of this list in a Redis database point of view. So what is list? You can consider list as a kind of group of numbers, or you can consider like a group of object or a group of string. So let's explore some of the commands of this list. We'll create a list, we'll pop some element from the list, we'll insert some element from the list. So before that, let's create a very simple list having just the one value. So there is a two commands possible. You can create the list like a lpush and rpush. So lpush is kind of from the left hand side you insert the element to the list, and rpush is kind of you insert the element from the right hand side of the list. So let's create a very simple one, like let's create a list of the heights, and we want to insert like, let's say random, anything like a 20. Okay, so we have inserted it. Let's say again we want to insert like 23. Okay, so first we inserted 20 and then 23. So from the left hand side we inserted, so it becomes 23 and then 20. Now let's say we want to insert from the right hand side. Same command we can use, but instead of lpush we'll use rpush heights, and from the right hand side let's say we want to insert like a 40. Let's insert another, let's say 45. So height here it becomes a key, and now our ordered collection of list will be something like 23, then 20, then we insert it 40 which is at right hand side, and again let's say 45. Okay, so let's see how we can retrieve this all the data. So we can just use lrange, and we can give the first argument as a key. So it's a index base, so there are total 4 elements are there, so we can just retrieve like 0 to -1, because it's a negative index also possible. So this is a 0th index, first index, second and a third. Once you give the -1, it's other way around, it will start the indexing. So it's a 0 and this is -1. So 0 to -1 will give list of all the value associated with the keys heights. Okay, so you can see 23, 20, 40 and 45. Let's just insert some more element. Let's say we want to insert 45 to 56. So it will append, as we are using rpush, so it will append to the right hand side. Let's again do the lrange. So it has appended at the last. Now if we want to append at a very head side or a left hand side, we can just simply use lpush. Let's say we'll push like a 38, and again let's do the lrange. So 38 has been pushed at the left hand side, and 56 what we have just now pushed, it is at the right hand side. Now instead of 0 to -1, let's say we want to grab first 4 elements, so we can just simply use like, so it will return total 5 elements, because 4 is also inclusive in this case. So if you want to get, let's say, first 4 elements, so we can just use 0 to 3. So 0, 1, 2 and 3 it will retrieve it. So 38, 23, 20 and 40. Now let's see some more commands. Let's say we want to see how many total elements are currently present in that particular list. So we can use like ln. So list length. So there are total 6 elements are currently present. Let's say we want to remove some element from the head or from the tail. So let's first display what are the elements we have. So we have a total 38, 23, 20, 40, 45 and 56. So we can either remove element from the very first or very last. So same way lpush and rpush equivalent deleting, or you can say popping up command like lpop and rpop. So I can just use like lpop. I'll just giving the keys. So it has written 38 because it's the first element, and from the left hand side I want to retrieve it. So 38 has been removed. Now let's just verify through this lrange command. So 38 has been removed. Now total only 5 elements. So 23, 38 has been removed. So 23 to 56. Let's use the, instead of lpop we'll use the rpop. So 56 has been removed, the very last element. Now let's again verify. So you can see that 56 has been removed. Now there are only 4 elements are there, because the first element we have removed through this lpop, and the last element we have removed through this rpop. Let's again do the lpop and let's see what happens. Lpop 23 has been removed now. So 20, 40 and 45. So 20, 40 and 45 has been removed. Now last command we have executed. So this is the way we can use this list in a Redis database. This list you can use it as a publisher and a subscriber system also. So kind of messaging system. So you can just publish some particular list of value to one particular key, and subscriber will just subscribe to that particular key, and once the publisher publish key, it will just use this lpop or l push or r push command, and it will keep inserting the data. So best way to go with you keep inserting data with r push. So keep appending, it will just keep appending data, and with that particular key subscriber can just subscribe that particular key, and it will just use this lpop, and continuously whatever the order in which the data has been inserted, it will just keep consuming those data. So this list in a the Redis database engine, you can use it as a publisher and a subscriber system also. So that is all about very simple and basic introduction related to list data structure in a Redis engine. I hope you enjoy listening this video. We will see some more data structure in a next video. Hi everyone. So let's discuss the another data structure in Redis database engine, and one of the another very important data structure like a set. So what is set? Set you can consider as like a unique sets of element. So no repeating element, you can just put it into set. And if you just compare with our earlier data structure what we learned in the last video, list is like a ordered collection of value. Instead of that, this set is like unordered, so it won't preserve the order, and duplicacy is not allowed in case of this set. Whereas in case of list, duplicacy is also allowed, and there is an ordered collection of value. So let's create a very simple set. So to add any value, we can just use s add, and we'll create a set having a key, let's say company, and we'll keep appending one company inside that. So let's just add Google. Okay, let's add another one. Let's say Yahoo, Microsoft. Now suppose we want to see that whether particular value is exist in a set or not. So we can just use like a sys member. So it's something like a set is a member of this particular key or not. So we can use SIS member. Then we can just give like a key company, and we can just verify whether Google exists in a company key or not. So it exists. Let's search for, let's say, Apple. So Apple is 0. That means Apple doesn't exist. Now let's try to add the same way Google again, and let's see what happens. So 0. That means already Google exists as a part of this company set and company key. So you just cannot add it again, because the main objective behind this set data structure is duplicacy is not allowed. So only unique sets of element will reside in a set data structure, and there is no order has been preserved. Now let's say we want to retrieve all the values available in one particular set or one particular key. So we can use simple s members. Along with that, we need to give the key. So there are total 3 values: Microsoft, Google and a Yahoo. Now let's remove one of them. So to remove, we can use srem. Company is a key, and let's just remove Yahoo. Okay, so it has written 1. That means Yahoo has been removed. Now let's again retrieve all the values in a company set. So now we have just 2 values. One is Microsoft and one is a Google. Now if you see here, the first we have added Google, and then we added Yahoo, and then Microsoft. After that we just retrieved this all the values, but there is no order has been preserved. So first value came as a Microsoft, even though we added a very last, and then Google we added a very first one, but still it is in a second. So order has not been this set data structure do not preserve any kind of order of the value the way we have inserted. Now let's say we want to see how many total values are present in a company key. So we can use as card, and we can just give like a key company. So there are total 2 values are present. Let's add a Yahoo again, and let's again verify. So there are total 3 values are there. Let's just display all the value. Now I have total 3 values are present: Microsoft, Google, and a Yahoo. Now let's create another set, and after that we will see what are the operations you can perform on a 2 different set, like intersection or a union or a difference kind of operation you can operate on a 2 different kind of set. So let's create another set. So instead of company, I'll just give org, so like a organization. In organization also, let's just add Google. Now instead of Google, we'll just add another like a Apple. Let's add one more, let's say Nvidia. Okay, so we have successfully created the another sets. Now let's just retrieve all the values in this organization. I like org. Okay, so now we have total 2 set. One is a company set and another one is a organization set. Now let's say we want to find the union of these 2 sets. So all the value but not repeating value. So we can use S union. The first data structure key we will provide like a company, and another one is a org. So you can see earlier we have added Google, Yahoo, and Microsoft. In a second one we have added Google, Apple, and Nvidia, but from the second set it has just taken this Apple and Nvidia because Google was already a part of the first list. So it will return the union of all the elements in both of the key. So key is here company and org. Org is I have just taken a shortcut for the organization. Same way, let's apply the command like a diff. S diff. Same way, company and org. So it will just return the difference between the 2 sets. So it will just return all the values in a first set company which is not present in a set 2. Now let's do the same way. Instead of company first, we'll do the organization first and see what happens. So Apple and Nvidia it has written. That means Apple it has taken all the values in a first list. First list here is a organization. So where we have put Google, Apple, and Nvidia, and then it has removed all the common element between both of them. So Google was a common, so it has been removed from here also, and Google was common here also, so it has been removed. So these are all some of the basic way you can deal with set data structure in Redis database engine, and that's all about this video. In the next video we'll see some more data structure in Redis database engine. Hi everyone. So let's discuss about another data structure like a hash. Hash is you can consider as like a key value pair mapping. Observe one thing here, that Redis itself is one of the big in-memory key value pair kind of database. So already Redis contains a key value pair kind of data set, and inside that also with one of the key you want to associate pairs of some keys and value, you can use this hash functionality. So hash will store the data like a corresponding to some key, corresponding some values are associated. So if you want to represent an object, this hash is one of the very good way of representing that particular object. Let's say we want to store the data of one of the student, so into hash kind of data structure in a Redis database engine. So we can just simply use like set. Now that particular student has a number of different properties. Let's say student name, or student score, or grades of the student. So we can just use like hash set. It's a student, so we can just use the, let's say, student 1. So corresponding to one particular student 1, we want to store all the properties. Now after that we can just add the property we want to store. Let's say we want to store like a name. Will keep it like, say, Alice. Same way, along with the name we want to store like a score this Alice has obtained. So let's say 72. Let's create another property like a age. So age is, let's say, 18. Okay, so we have created one hash data key which is a student 1, and having a total 3 key value. One is a name, score, and an age. Now let's say we want to grab some value, so we can just simply use like a get. Then we'll just supply the key. Key is nothing but a student 1, and then name. So name is Alice. Let's say we want to get score. So score is 72. Let's retrieve the last property, age. So age is 18. Now instead of just one value, let's say we want to insert a multiple value, or we want to retrieve or fetch multiple value in a one single command. So instead of just add set, we can use hm set and hm get. So let's first use the hm get. So hash multiple get hm get student 1, and I want to retrieve age and a name. Let's say I want to retrieve all the 3, age, name, and score. So the order in which we provide the key, it will return the result in a same order. So age is 18, name is Alice, and a score is 72. So now let's see how to insert in a one single specific command only. So instead of just writing 3 different commands for the 3 key value pair associated with this student 1, let's see in a one single line how we can do it. So let's create another student 2. So to insert it one single command, we can use like a hm set. I am just changing it to student 2. Let's define name is equal to, let's say, Bob. Age is equal to, let's say, 16, and score is equal to 55. Okay, so we have successfully inserted through just single line of command. So here we used the 3 different commands using set and get. Now let's just retrieve through this hm get. So hm get, instead of student 1, let's just retrieve for the student 2. So age is 16, name is Bob, and score is 55. Now let's see another variant of this hm get command. So here we have supplied what are the keys we want to retrieve. One is age, name, and score. Let's say we don't know what are the keys are there, and we want to retrieve all the key associated with this hash student1 or a hash student2. So instead of hget or hmget, we can use hgetall. So hgetall, and we can just simply supply the key like a student1. So name Alice, score 72 and age is 80. Same way, let's retry for the student2. So another 6 value it will return. So first is the first, third and a fifth are the key, second, fourth and a sixth are the value associated with that corresponding key. Now let's say we want to find whether particular key exists in one particular hash, let's say student1. So whether name field exists in a student1 or not. So we can use hexist. Let's say student1 name. So it has written 1. That means hash corresponding to the student1, the name key already exists. Let's say instead of checking for just name, we'll check for the name 1. So it has written 0. That means the name 1 doesn't exist corresponding to hash the student1, but name exists corresponding to the student. Now let's say we want to increment some of the values corresponding to some key. Let's say we want to increment the score, or we want to increment, let's say, age corresponding to hash student1. So we have a command available like a incr by. We can just use like a student1 and which particular field we want to increment it. So let's say we want to increment score. So earlier our score was corresponding to student1, it was a 72. So let's say we want to increment it by 5, so it becomes 77. Let's just use hgetall student1, so it becomes 77, and it has written 77 also here. Now let's say we want to see how many total keys are present corresponding to some hash. So we can just simply use hlen student1. So there are total 3 keys are present. Let's say corresponding to student2. Student2 also associated with the 3 keys. Okay, so we have almost covered majority of command associated with this hash data structure in a Redis database engine. So that's all about this video. See you into next video. Hi everyone, welcome to the new section on persistence in a Redis. So in this section, couple of video we are going to discuss about what is the persistence mechanism is available in a Redis. So Redis is mainly a in-memory database, but Redis can still store the data into disk also. So if you want to persist your data, you want to retain your data and store it to some other place or some remote location or something like in a Amazon S3 level machine. So you can easily take the backup of your data and transfer your same file to the other machine very easily. So how this persistence is done in a Redis? Now if you think a very general way how persistence can happen, there are 2 ways possible. We can persist database data into hard disk location or hard disk storage like file storage. After every periodic interval we can take a snapshot. So after every periodic interval we can take a snapshot, let's say 60 seconds, or we can take like a once in a day or twice in a day. And there is another mechanism we can do. As and when the query comes, just write it into, so instantaneous you can say. So whenever the new query will come, it will immediately write those log to the some sort of file. So to tackle this both of the way to persist the data in a Redis, there is a 2 mechanism equivalent to this periodic interval. There is a mechanism called RDB. So it's kind of a point in time snapshot. So after every periodic interval you take a snapshot and dump your all the live data available in the memory to your predefined Redis database file. And another one is a instantaneous. So for that, append only file. So whenever the new query will come, based on some syncing policy, it will just append that particular data immediately to that particular file. Now both of the route has their own advantage and a disadvantage. So let's first discuss about RDB, and then we'll discuss about the AOF. In our next video, we'll see both of the things into action, that how to configure and make it enable both of the option or either of the option. So let's first discuss about the RDB, the point in time snapshot. So RDB you can consider as one of the simplest kind of persistence mechanism available in a Redis. So it's a very simplest. It's by default enable. So to make it enable, you do not need to do any kind of configuration setup. So no configuration. It by default enable. It's a very easy to use. I'll show you with simple command like a save or a bg save. It's like a save and a background save kind of very simple command. You can take a snapshot of that. So whenever the new the file has been created of your dump, its file is also very much compact, and it has one more advantage compared to this AOF option is like whenever you restart the server, it will very fast, it will load the data into Redis memory, so very much faster. So while taking when you take a snapshot, it creates one .rdb file, and the location of this RDB file has been given in redis.conf file. So it's a configuration related file in a redis.conf, and whatever the data dump will do, it is available in a .rdb file. So it's a dump.rdb. To save your data or persist your data in a RDB mode, we can use the two commands like a save and a bg save. So it's one of them is a background save and another one is a save mode. So what is the reason behind giving these two different commands or two different API to save the snapshot data is that when you use this save command, let's say in a production environment you are running this save command, in that case all client will be blocked and it will start serving the snapshotting related part. So the thing is that both of the things, all the client serving part and this saving snapshot runs on a single thread. So all other client which needs to be served at a priority, those got immediately blocked. So that's why another option like a bg save. So while doing a development time, at that time some sort of debugging or any other purpose, you can use save, but on a production level environment it is highly recommended not to use this save, but you can use this bg save. So another child process will be created, exact replica of that parent process only, and that particular child process will use this bg with the help of this bg save command. It will start taking a snapshotting of your full database available in a Redis database memory to your persisted this dump.rdb file. Now there are some disadvantages associated with this RDB kind of approach. So let's say you want to take a snapshot of after every periodic interval, so you should be ready to lose your data. So get ready to lose your data, or you can say the latest data, your latest data. In case let's say Redis somehow got shut down, or already the data is available in a memory but it has not yet persisted. So let's say you are taking the snapshot after every periodic interval of 1 hour, so you should get ready to lose your data of last 1 hour. So this mechanism is not a completely durable thing, whereas in case of this AOF we will see that it is in a append only file. So whenever the new query will come, it will immediately append it. So let's say it has a periodic interval of just 1 second, so in that case you will lose the data of just 1 second of data, but here the more bigger the periodic interval, you should be ready to lose more amount of data. Let's say another variant with the help of this save command or bg save command. What are the another parameter you can pass on? So rather than just saving, if you want to, let's say, save after every 60 seconds, or let's say 120 seconds you want to save those things, so you can just use like a save 120 seconds. With that another parameter also you can pass, like let's say after every 120 seconds you take a snapshot, provided if at least 1000 modification has been done to the Redis database engine. So there are another two parameter also this Redis will give along with this save and bg save command. So first is a second, after every periodic interval you want to take a snapshot, and second parameter will give us that take a snapshot after every 120 seconds, provided if 1000 keys or any kind of 1000 modification has been done to server, then only take a snapshot, otherwise don't take a snapshot. Now let's discuss about the another option like AOF. AOF is kind of, you can say that it's a more durable option, and it has a number of syncing policy also. So after how much interval of time you want to save your data, let's say as and when the new query will come, you want to save the data, or after every 1 second of durable time you want to save the data. In that case you will just lose the data of 1 second only. One main advantage of this end of the file AOF mechanism is that every time the new query will come, every single query will be able to logged. So it's an instantaneous option. So once you write the data into database memory, with the help of this app sync policy, the data will be synced and persisted to the actual hard disk location. So we'll see what are the options are there in this app sync policy. So there are three kinds of app sync option are available. So first one is no app sync. So there is no syncing will happen, and automatically after some interval of let's say 30 seconds, it will automatically take a snapshot or kind of snapshot, but and put it into this append only mode. So one is a no syncing policy, another one is a every second policy. So after every second, whatever the data has been logged or query came to the Redis database engine, it will log to the append only file mode. And another one is a rather than every second, you want to log the data at every query. So you can think about that in a 1 second, let's say 1000 query will come. So after every query, it will start writing to the dump file. So that will be a kind of very much slow. So if you are ready to lose your data of just 1 second, it is recommended to use this every second policy, and it's by default policy also available in a append only file mode. This AOF file also takes larger spaces compared to this RDB file, so require large size compared to RDB file. One disadvantage is that this AOF takes a longer time to load all of your persisted data into memory. So whenever restart will happen, you want to load your AOF persisted file, AOS persisted data into memory, so it takes longer time to after restart, and it is a little slower also compared to RDB while taking snapshot. So depending on which kind of this app sync policy you use to take which kind of app sync policy you use, depending on that it will be slow or fast compared to this RDB. So little slower, because you can think about it every single second or with every single query it will start syncing your data from Redis database engine to this append only file. So it's a little slower compared to RDB. Okay, so these are the main features are associated with these two persistence mechanism available in a Redis. One is the RDB, and in a another one is a AOF. So in the next video we'll see how to use this save and bg save command of this RDB, and how to enable this AOF only mode, and what are the configuration you need to perform. So that's all about this video. See you into next video. Hi everyone, welcome back. So in this video, in the last video, we have already seen what is the theory associated with the two persistence mechanism available in a Redis. So one is RDB and another one is AOF. So in this video, we'll see this RDB. Let's first go to where this RDB dump file is located. So I have already opened two instances from this command line prompt to my Linux based machine. So I'm just opening that RDB file, and let's see where this RDB file is located. The path has been configured in a redis.conf. So I haven't changed any kind of path, so it's a default path I'm going to see. So where lib redis dump.rdb. So you can observe the location where lib redis dump.rdb. Now let me just open it. So it contains nothing because there is no data has been saved into this particular file. So let me just come out. Now let's go to the another tab, and we'll start the Redis CLI. Now let's put some data to this Redis database engine. So let's say set, very simple, like key1 val1. Let's put another one like a key2 val2. Okay. Now we can use the save command or a bg save command. I have already explained you the difference between the save and a bg save. Here we are not in a production mode, or we don't have a huge amount of data, so it will block all the client. Let's just simply use this save command. So it will save this 2 key to dump.rdb file. So by default this RDB option is enabled, so we don't need to worry about whether we need to do any kind of configuration or not. Now let's go to the another tab, and we'll again open this particular file, and let's see. So you can see that now key1 and a val1 and a key2 and a val2 has been available in this dump.rdb file. So in this way we can just simply use this save command, or you can use this bg save command and take a snapshot of whatever the data available in memory and put it into this particular place. So rather than just the save, I have already explained you that you can use like after how much interval of time you want to retain your data. So you can just give like after every 1000 seconds we want to retain the data, or after every 60 seconds, or once in a day we want to retain data. You can just give option with the help of this save command. That's all about this video. In this video we have seen how to persist your data in a RDB mode. In the next video we'll see how to persist your data with AOF only mode. Hi everyone. So let's discuss about another append only file mode into action. So in this video we'll see how to enable the configuration related to this append only file mode. So for that we need to do the configuration at two different places. Before that, let's just see what are the file exist in where lib redis directory. So let's just go to where lib redis, and I'm just going to do listing the file. So we have only one file is available from this dump.rdb file through this RDB mode what we have created in a last video. So first let's just start Redis CLI. Okay, and we need to start like bg rewrite AOF. So you can see that it's saying that background append only file rewriting started. Let's just come out from here and let's just again see ls-lrt. So you can see with 0 KB append only.eof file has been just now created. So this is the one configuration through this Redis command line interface we need to do. Now another configuration we need to do into Redis conf file. So I'm just going to open this Redis conf file because we need to change some configuration. We can do through this nano editor or vi editor also. So I'm just going to do it from here. So etc Redis. So we have this redis.conf file available on a same machine. So I'm just opening it with a default text editor. Okay, inside it just search for append only. So you can see this append only mode is currently no and it is commented. So let's just uncomment it and make it yes. So to enable this append only mode log writing, we need to make it on and just press Ctrl S. So it is saying that you want to upload your modified file to the server. So yes to all. Now we have changed the configuration. That means we need to restart the server to make our configuration change into effect. So let's just change. Let's just stop the Redis server first. So service Redis stop. Same way we'll start again Redis services. So service Redis start. So you can see now Redis service has been started with append only mode is yes. Now let's just go, let's just open this, I'm just going to open with a nano editor only, this append only file. So you can see there is nothing inside the file. Now let me just open this Redis CLI. We'll put some data and again we'll observe this append only file mode. So let's just put set for, let's say 39, and let's say another one like hello 100. Okay, now let's just come out from here and let's just observe this append only .aof file, and I'm just going to open this append only .aof file. So we have executed two commands and both the command entry has been logged. So you can see foo has been written like a 39 and another one is hello is 100. So after every 1 second or maybe whatever the policy has been set into current configuration file, you can change and experiment with a different policy after every second or after every query you fire for the this Redis database engine, how it is going to write into this append only file mode. So that is all about the how you can enable this append only file mode to take a backup of your data. So that's all about this video. See you into next video. Hi everyone, welcome to the course on Learn in-memory database Redis from the scratch. So I am Ankit Mistry, having a 8+ years of experience in a software industry, is going to become an instructor for you in this course. So let's see what we are going to cover in this course. So I have divided whole this Redis course in a multiple section. So in a first section we are trying to understand what Redis is, and we'll try to cover a basic introduction of Redis, mainly a theoretical aspect of Redis. In the next section we'll see how to install this Redis on a Windows and a Linux based Ubuntu system with an in-depth tutorial. Then we'll go towards a basic Redis command. We'll try to cover most of the command through some demo. And then we'll learn about some of the very important data structure available in a Redis, like list, hash, set. And in the last section we'll see one of the very important concept of the Redis, a data persistency in a Redis. Even though Redis is an in-memory database, you can still store this data into your secondary memory on your hard disk and you can persist data. All this section covers with in-depth theory and a detailed video lecture covering the demo, how to execute the command in each and every video. Each section will comprise of the quizzes which will actually test whether you have really grasped the concept associated with that particular section. So as a part of prerequisite, there is nothing specific prerequisite. You should be curious enough to get to know about in-memory database. Already a database developer or a web developer or a software developer, everyone is very much welcome to sign in into this course. Along with this course, there is always 30 days money back guarantee, so there is nothing to lose at your end. So what are you waiting for? Please enroll it today and start putting your data in a memory, and I will see you in a field.